Why do we demand particular goods and services? We do it because they make us happy. And in this module, we will learn that economists have a special term that they use to describe our happiness. The word used by economists is utility. And remember, part of understanding economics is about almost learning a new language. It's not completely a foreign language, but economists use terms that are specialized to describe things that we do every day. So what we might describe as happiness or satisfaction, economists refer to as utility. So you are going to hear that word utility over and over again in this module, because module 51 is all about what we call utility maximization, or how consumers maximize their utility. Another way of saying that is, how do consumers maximize their happiness or their satisfaction through the consuming purchases they make? So in this module, the final module of Unit 3, looking behind the demand curve at consumer choices, is that we will describe first how consumers make choices about the purchase of goods and services. We'll explain why consumers' general goal is to maximize their utility. I'll explain why the principle of diminishing marginal utility applies to the consumption of most goods and services. And once again, we'll use that economic tool of marginal analysis to find the optimal consumption bundle. So let's begin. At the beginning of this module, I use that term utility, and you're going to hear that term over and over and all again. To economists, utility is all about getting satisfaction. Our utility is our happiness. Our utility is our satisfaction. The amount of utility we get out of something is the amount of satisfaction or happiness that we get out of something. So the utility of a consumer is a measure of their personal satisfaction. And an individual's consumption bundle is the collection of all the goods and services consumed by that individual that give us utility, that give us happiness. That's why we purchase them. So an individual's utility function gives the total utility or total satisfaction or happiness generated by his or her consumption bundle. Now, economists have a special unit of measurement that they use to describe utility, and of course this you'll find funny because of course they would. It's called a util. So whenever you hear me describe the number of utils that someone has, we might refer to them as happy points. That's how I tend to refer to a util. You know, a util is a happy point. And consumers are always trying to increase the amount of happy points they have, because the more happy points you have, the more satisfaction or happiness you have. So to economists, they would say the more utils you have, the more utility you have, the more happiness or satisfaction you have. And that's what falls behind our decision to make purchases, to consume goods and services. So when we look at consumer choices and we look behind what motivates them, behind the demand curve, it's all about getting satisfaction. So utility then is a measure of the satisfaction the consumer derives from consumption of goods and services. Now, utility is a subjective notion in economics. We don't expect to really measure it. There's no way of really going out and exactly measuring the amount of utility you get from every purchase you make. But consumers know intuitively when their utility is rising or falling. You know intuitively when you're getting happier or less happy, and when you're getting more satisfaction or less satisfaction. And as a consumer, you know when one choice provides you with more utility than another choice. That's why you make it. So we're going to refer to utils as happy points in this module rather than utils, because I think you might understand that a little bit better. But realize that in your textbook and in other places, oftentimes economists will refer to this as utils. Now, as we begin to look at utility and our consumption choices, we might begin by looking at something that people might want to consume, like a Slurpee. Okay? And so here is a chart that shows the number of Slurpees that we could potentially consume in a week. Now, for now, we are assuming that Slurpees can be consumed without purchasing them. So, if we were to plot the total utility function, we would do so by plotting total utility on the horizontal axis. Now here, we're looking at a consumer named Cassie and the utility she gets from consuming clams. If we were to plot this, we would plot the quantity of clams that she would consume on the x-axis, and we would plot her total utility in utils, or happy points, on the y-axis. Now let's go back to the previous screen and look at our Slurpees. Okay. The first column shows us the number of Slurpees we would consume in a week. The second column shows us the total utility that we received from consuming that number of Slurpees as measured in utils, or happy points. So if we consume one Slurpee in a week, we have 40 happy points. If we consume a second Slurpee, it's 70 happy points. If we consume a third Slurpee, we have 90 happy points, and so on. Now, the third column shows the marginal utility we get from consuming each Slurpee. Remember, the marginal utility is the additional utility we get from each. So when we consume the first Slurpee and we have a total of 40 happy points, we go from 0 to 40, that's an additional 40 happy points. If we consume 2 Slurpees, we have a total utility of 70 points, but that's only 30 points more than 1 Slurpee. So our marginal utility from the second Slurpee is 30 points. If we consume 3, we get an additional 20 happy points. If we consume 4, 10 happy points, 5, an additional 5 happy points. But if we consume 6 Slurpees, that's too many for us, and our happiness actually goes down. We lose 15 happy points by consuming 6 Slurpees in a week, and so our total utility would only be 90. Now if we graph this, looking at Cassie and her consumption of clams, we get 2 different functions. In graph A, we have her total utility function, and you can see that the more clams she consumes, the more her total utility rises. But the slope goes down as she consumes more. Why? Because her marginal utility, as shown in graph B, is declining the more clams she consumes. The first clam she consumes gives her 15 happy points. If she consumes 2, she gets another 13 happy points. A third one gives her another 11 happy points, and so on. So Cassie is happier by consuming, but she gets the most happiness from the first clam she consumes. She gets some more happiness from a second clam, but not as much as the first one. She gets some more happiness from the third one, but not as much as the second one, and so on, until if she consumes 9 clams, she reduces her happiness because maybe she starts getting sick of clams, or she's getting tired of them. And so we have to know how to graph the total utility function for any consumer good and the marginal utility function for any consumer good. You should be able to graph it and interpret what it means. So Cassie's total utility depends on her consumption of fried clams. If you go back to the previous screen, you'll notice that it reaches its maximum utility at a total of 64 happy points. And that is with a consumption of 8 clams. And then after that, her happiness begins to decrease if she consumes any more clams. So the marginal utility curve slopes downward due to what we call diminishing marginal utility. With each clam we consume, we get some additional utility, but it's less than the utility we got from the previous unit, and so we say there is diminishing marginal utility. Each additional clam gives Cassie less utility than the previous clam. So most of the time, we make our consumption decisions about any good or service incrementally, at the margin. For example, making a decision at the margin means saying, should I consume a third Slurpee after already having 2 this week? The answer is simple. Yes, you should consume a third Slurpee if it increases your total utility. If it subtracts from your total utility, then you should not have a third Slurpee. The incremental change, an addition or subtraction to total utility, is what we call marginal utility. And it can be shown this way. Marginal utility is equal to the change in our total utility divided by the change in our consumption of good X. So the total utility of 2 Slurpees equals 70 happy points. The total utility we get from consuming 3 Slurpees is equal to 90 happy points. So the marginal utility of the third Slurpee is equal to 90 minus 70 divided by 1, because it was an addition of 1 Slurpee, and that is equal to 20 additional happy points. So if we go back to this chart here, you can see the marginal utility that we get from consuming additional Slurpees in a week. The marginal utility function slopes downward, as we see here, due to the principle of diminishing marginal utility. The principle of diminishing marginal utility says the additional satisfaction or additional utility, meaning marginal utility, that a consumer gets from consuming one more unit of a good or service declines as the amount of that good or service consumed rises. And that is true for any good or service. So how many Slurpees should this person buy in a week? 5. The 6th Slurpee has negative marginal utility, which means consumption of it will actually decrease total happiness. So even though marginal utility is smaller and smaller as Slurpee consumption rises from 1 to 5, as long as the marginal utility is greater than or equal to 0, the consumer will choose to consume it. So this formula here is the one that we use. This formula means that the marginal utility is the slope of the total utility function. Look again at the graph of total utility, and notice that the slope of total utility is positive but getting smaller as we move from 1 to 8 clams. The slope becomes negative beyond 8 clams. Now, if you look at the shape of the marginal utility function, you will see that it is declining, but once we reach the 8th clam, marginal utility becomes negative and goes beyond the horizontal axis. So, to sum up this section of the module, we know that the marginal utility of a good or service is the change in total utility generated by consuming one additional unit of that good or service. The marginal utility curve shows how marginal utility depends on the quantity of a good or service consumed. And the principle of diminishing marginal utility says that each successive unit of any good or service we consume adds less to total utility than the previous unit. And that is true of any good or service we consume. Now, some people might ask the question, is marginal utility really always diminishing? Are all goods really subject to diminishing marginal utility? Of course not. There are a number of goods for which, at least over some range, marginal utility is surely increasing. An example is something that's popular here in Colorado, alpine skiing, which involves more fear than enjoyment at the start. But then, after a while, it becomes pleasurable after it is mastered. So why does it make sense to assume diminishing marginal utility? Because most goods don't suffer from the above qualifications. In the relevant range of consumption, marginal utility is still diminishing, even for something like skiing. So now we have to relate the principle of diminishing marginal utility to our budgets and optimal consumption, because up until now we've assumed that we can continue to consume without it costing us anything. But we know in the real world that's not true. When consumers consume something, they have to give something up for it. And each consumer is constrained or limited in their purchase of goods and services by their budgets. And every consumer has a different budget. So a budget constraint requires that the cost of a consumer's consumption bundle be no more than the consumer's total income. A consumer's consumption possibilities, therefore, is the set of all consumption bundles that can be consumed given that consumer's income and prevailing prices. An individual consumer's budget line shows the consumption bundles that are available to a specific consumer who spends all of his or her income. Now we assume that consumers want to maximize their utility. but each consumer must do so within their own individual budget constraint. This is described as constrained utility maximization. The consumer has two challenges. Number one, to find the bundles of goods and services that are affordable given their income and current prices, and to choose the bundle that provides the highest utility or satisfaction to that consumer. So let's look at an example. Let's assume we have a consumer named Bruno. And Bruno has an income that we will call I, or say his income is $50. So his choices that he has are limited or constrained by his $50 income. We'll say that the price of a notebook, PN, is equal to $5, and the price of a CD, PCD, is equal to $10. So using this information, we can construct his budget constraint and graph his budget line. The equation will be that his income of $50 is equal to $5 times N plus $10 times CD, where N is the amount of notebooks purchased and CD is the amount of CDs bought. This equation simply says that Bruno's income must equal the amount of money he spends on notebooks at $5 each plus the amount he spends on CDs at $10 each. It is a constraint or limit because he cannot afford a bundle that exceeds $50 of total spending. So, if we graph it, we create Bruno's budget line. Now, what can we learn from graphing his budget line? Well, this is the consumer possibilities curve, and it looks very much like the production possibilities curve that we learned in Unit 1. But production possibilities limit the production of a good or service. When we can talk about a consumer possibilities curve, it is their budget line, and it limits what a consumer can purchase given current prices and their income. So there are some things that are going to look similar to us from the production possibilities curve. First of all, any point inside Bruno's budget line is affordable, but it doesn't use all of his income. Point A, 2 notebooks and 1 CD, is affordable, but he only spends $20 to do it. He doesn't spend all of his income. Assuming Bruno could be happier spending more of his income on these 2 goods, a point like A would not maximize his utility. It would be affordable, but not desirable. Points along the budget line are affordable, and all of the income is spent. So point B, 6 notebooks plus 2 CDs, adds up to exactly $50. The vertical and horizontal intercepts are 2 additional points where exactly $50 are spent. He could buy 5 CDs and no notebooks, or 10 notebooks and no CDs. Or he could buy any combination of notebooks and CDs that are on the budget line, and that would maximize his utility by spending all of his income. The slope is also informative, as we'll find out. Now, a point like C outside the budget line is unaffordable. It might be desirable. He might like to have 6 notebooks and 5 CDs, but he can't afford them. So that would require $80 of income, but he only has $50 of income. Point C might make him happier than point B, but he cannot afford it. The slope of this curve is also informative. In this curve, the slope equals -2. This tells us that in order to buy 1 more CD, he must give up 2 notebooks. In other words, it represents the opportunity cost of a CD. 1 CD costs him 2 notebooks, and 2 notebooks cost him half of a CD. So we can also learn the opportunity cost of a choice from this graph. Here we see Sammy's budget line when it comes to clams. Notice the shaded area under the budget line. Those are all affordable but not desirable. Those are combinations of clams and potatoes that Sammy could afford given his limited income and his limited budget, but it would not be desirable because it wouldn't be spending all of his income. Points A, B, C, D, E, and F all represent points on his budget line that cost him all of his income, and they're the combinations then that are desirable and affordable. Anything outside of the budget line is a combination that is unaffordable, even though it may be desirable. Here you see Sammy's utility or happiness from clam and potato consumption. So here it shows us combinations of clams and potatoes, and now we add the utility function to it to find out how much happiness he gets from consuming different quantities of clams and potatoes. And so to the left side of this graph, we see different quantities of clams and the happy points that he gets from consuming those quantities. Then, on the right side of the graph, we see his utility from potato consumption, and with different quantities of potatoes, the amount of happy points he gets from different combinations of potatoes. So the question is, if Sammy has to choose a combination of clams and potatoes from his budget line that will make him happiest, what combination will he choose? Combination A, B, C, D, E, F, or some other combination? He's going to want to choose the combination that gives him the greatest total utility. So the question is then, well, how do we figure it out? How do we figure out the optimal consumption bundle? Because all of the affordable bundles can work, but which combination should Bruno choose to maximize his utility? Which combination of clams and potatoes should Sammy choose to maximize his utility? Well, to answer that, we need a little more information. Now, before we get that information, I'll tell you that the optimal consumption bundle is the consumption bundle that maximizes a consumer's total utility given his or her budget constraint. So this table shows how much utility Sammy receives from the consumption of notebooks on the left-hand side and from CDs on the right-hand side. But we need to focus only on the combinations that lie upon the budget line. So, for example, we could look at a combination of 2 notebooks and 4 CDs. That provides him with 330 happy points. But can he do better? Yes. If we look at this graph, if he consumes 4 notebooks and 3 CDs, that gives him the maximum total utility. He gets 390 happy points from doing so. And that is a greater number of happy points than any other combination on the graph, given his budget line. So, again, if we look at Sammy and his combination of clams and potatoes, we see that he gets his greatest total utility or greatest amount of happy points if he consumes 2 clams and 6 potatoes, because it gives him a total utility of 72 happy points, which is greater than any other combination of clams or potatoes that he could consume, given the constraints of his budget. Now, when we graph these, given Sammy's budget line, you can see the optimal consumption bundle is combination C, 6 pounds of potatoes and 2 happy points. If we match that up to his utility function in graph B, where we see the total utility that he gets from different combinations of clams and potatoes, you can see that point C is where his total utility is maximized given his budget constraint. And that leads him to choose to consume 2 pounds of clams and 6 pounds of potatoes. Now, another way to think about Sammy's problem or Bruno's problem is to think about their spending decisions incrementally. If he has $1 to spend, how should he best spend that dollar? Should Bruno spend that dollar buying another notebook or another CD? Should Sammy spend that dollar purchasing another pound of potatoes or another pound of clams? Well, the answer is they should probably spend that dollar on the item that will increase their utility by the most happy points. If they go through life spending the next dollar on the thing that gives them the highest marginal utility for that dollar, they are bound to maximize their utility. So we first have to modify the table to create something called marginal utility per dollar spent on a good. And that is going to be equal to the marginal utility of 1 unit of the good divided by the price of 1 unit of the good, or the marginal utility of the good divided by the price of the good. So to get marginal utility per dollar, it's the change in total utility divided by X, and to get marginal utility per dollar, we just divide this by the price of X. So when Bruno goes from 0 notebooks to 2 notebooks, his total utility increases from 0 to 70. Happy points is shown here. And notebooks cost $5 each. So the marginal utility is equal to the 70 happy points divided by the 2 notebooks, and that equals 35. So his marginal utility is 35 per notebook divided by the price of a notebook, which is $5, and that is equal to 7. This tells us that each dollar he spends on the first notebook gives him 7 additional happy points. Now, we can complete the rest of the table in similar fashion. So if there are 4 notebooks, if he consumes 4, his total utility is 130. So we divide that by 4, and then that becomes our numerator, and divide that by 5, and that gives us 6 happy points spent on that that we received from that last notebook. We can do the same thing with CDs. Okay? Now, how do we know? Well, we already know from trial and error that Bruno maximizes his utility by consuming 4 notebooks and 3 CDs. But we can see in this table that this bundle has an interesting outcome. The marginal utility per dollar is equal for both goods. Notice that when he consumes 4 notebooks, his marginal utility per dollar spent on notebooks is equal to 6. When he consumes 3Ds, his marginal utility per dollar spent on CDs is also equal to 6. This condition is often described as the utility maximization rule. In other words, the rule that shows us the combination of 2 goods that should be purchased to maximize an individual's total utility, assuming that the consumer is spending all of his income on those 2 goods. And we are assuming that the consumer should do that. Here, we see Sammy's marginal utility per dollar. And you can see here that if you look at the marginal utility per dollar of clams and the marginal utility per dollar for potatoes, where do you find that they are equal to each other? What combination would give him the greatest satisfaction? Well, what you want to do is to look to see where the 2 may be equal to each other. And see if you can figure out what combination that's going to be. Notice that that's going to be 4 pounds of clams, because his marginal utility per dollar is 75 cents there, and it would be 10 pounds of potatoes because his marginal utility per dollar is equal to 75 cents there as well. So when they're equal to each other, that is the combination that will give him the greatest satisfaction. Now, can we come up with a rule for this? Is there a formula for utility maximization? And actually there is. Okay? As long as one good provides more utility per dollar than another, the consumer should buy more of that good to maximize utility, and there's a reason for that. Okay, so now this is the formula. So to maximize utility, the marginal utility of one good divided by the price of that good must be equal to the marginal utility of another good divided by the price of that good. And that is the combination of those two goods that will maximize our utility. Now, think about this. Why is this true? Because as long as one good provides more utility per dollar than another, the consumer should buy more of that good to maximize utility. But as more of that good is bought, because of the principle of diminishing marginal utility, its marginal utility continues to diminish until the amount of utility per dollar is just equal to that of the other good. So what if the marginal utility of one good divided by the price of that good was greater than the marginal utility of another good divided by the price of that good? Well, you're getting more bang for your buck with good X, so you want to consume more of it. This requires that you decrease your consumption of Y. But what happens to the marginal utility of X when you consume more? The marginal utility of X falls. And as you consume less of good Y, the marginal utility of Y increases. So as you consume more of X, you consume less of Y, and this kind of reshuffling will cease when the mu of X divided by the price of X is equal to the mu of Y divided by the price of Y. Thus, when the ratios are equal again. And we can see this in Bruno's case. Suppose he is consuming 8 notebooks and 1 CD. This is 1 point on his budget line, so we know he can afford it. But if this combination, the marginal utility of notebooks divided by the price of notebooks is equal to 4, and the marginal utility of CDs divided by the price of CDs is equal to 8. So the last dollar he spends on CDs gave him 8 happy points, and the last dollar he spent on notebooks only gave him 4. So this tells us he is spending too little money on CDs and not enough money on notebooks. Suppose he buys one more CD at a price of $10. This second CD gives him 70 more happy points, and he must give up 2 notebooks at $5 each to afford the second CD. So going from 8 notebooks to 6 notebooks lowers his total utility by 40 happy points. So he gains 70 and loses 40 in this small reshuffling. His total utility has risen by 30 happy points in doing so. And so at this new combination, the marginal utility of a notebook divided by the price of the notebook equals 5, and the marginal utility of a CD divided by the price of the CD equals 7. Again, he should buy more CDs and fewer notebooks, and his total utility will continue to rise until further reshuffling won't increase utility. And at that point, and only at that point, will the marginal utility of notebooks divided by the price of notebooks equal the marginal utility of CDs divided by the price of CDs, and that will be equal to 6. When it comes to Sammy and his consumption of clams and potatoes, if we graph the curve for the marginal utility of potatoes divided by the price of potatoes going in one direction, and the marginal utility of clams divided by the price of clams going in the opposite direction, what you will see is that when he is consuming different quantities of clams and potatoes, he needs to increase his consumption of one and decrease his consumption of the other until they are equal. And notice there is only one point where these two curves cross. At the optimal consumption bundle, the marginal utility per dollar spent on clams is exactly equal to the marginal utility per dollar spent on potatoes. And that is at a quantity of 2 pounds of clams and 6 pounds of potatoes. And so that is the combination of clams and potatoes that will maximize his utility. And so by using the utility maximizing rule, where the marginal utility of one good divided by the price of that good is equal to the marginal utility of the other good divided by the price of that good, where they're equal to each other, that is the combination that will maximize utility. And so if they are not equal to each other, you have to increase your consumption of the good that gives you more happy points and decrease your consumption of the good that gives you fewer happy points. Because as you do that, the law of diminishing marginal return says that the one that's giving you more happy points will decrease as you consume more of it, and the other one will increase as you consume less of it until the ratios are equal. And that maximizes your utility. And that is how consumers make their choices about the combination of goods and services to consume to maximize their utility or their satisfaction and happiness. So in this final module in Unit 3, which is entitled Behind the Demand Curve, looking at consumer choice and how consumers make choices in a free market, we've learned in Module 51 on utility maximization that consumers maximize a measure of satisfaction called their utility. Each consumer has a utility function that determines the level of total utility generated by his or her consumption bundle, the goods and services that are consumed. A goods or services marginal utility is the additional utility generated by consuming one more unit of the good or service. We usually assume that the principle of diminishing marginal utility holds true in all situations, that consumption of another unit of a good or service yields less additional utility than the previous unit. A budget constraint limits a consumer's spending to no more than his or her income. It defines the consumer's consumption possibilities, the set of all affordable consumption bundles. An individual chooses the consumption bundle that maximizes total utility. That is called the optimal consumption bundle. And the optimal consumption rule, or the utility maximization rule, says that at the optimal consumption bundle, the marginal utility per dollar spent on each good and service, the marginal utility of a good divided by its price, is the same. This concludes our look at Module 51 on utility maximization. It also concludes our work on Unit 3, Behind the Demand Curve, Consumer Choice.